Okay, so this is another video to answer any lingering questions about limiting reagent and percent yield. Now, this is a problem that we did earlier in the previous video. I rewrote it here just to show you guys real quick that we took the given amount of grams for each compound, converted it to moles, and then we were able to identify which was the limiting reagent. So at this point, we know that calcium is going to be the limiting reagent, which means that's the one that's going to run out first. Now, you might see a question that says, how much calcium phosphate will be produced in this reaction? So here's the balanced chemical equation, and here's a calcium phosphate. So what this question is asking is how much calcium phosphate is going to be produced in this reaction. Now, this is just a stoichiometry problem. It's a problem that you should already know how to do, but there's a slight difference. Now, for this type of stoichiometry problem, okay, you have to know where to begin. Now, where do we start? Well, we know from the previous problem that this is the limiting reagent, okay? And we know that this is going to run out first. So once this compound is done, then the reaction stops and you can no longer produce calcium phosphate. So that's why we have to choose the limiting reagent to calculate how much calcium phosphate is going to be made. So let's go ahead and start. Now, we know that calcium is the limiting reagent. So we're going to take the calcium moles that we have, which is 0.265, okay, moles of calcium. Okay, we're going to put those over 1, and then we're going to multiply by the mole ratio. Now, the mole ratio, again, is just a fraction of the numbers of the coefficients in front of the compounds, right? Now, the mole ratio, since we're using the moles of calcium, has to be the mole ratio of calcium to calcium phosphate. So the ratio here is 3 to 1, right? Now you always make sure you set up your mole ratio in terms of moles that I want over moles that I have. I want moles of calcium phosphate, so I know that 1 mole of calcium phosphate needs 3 moles of calcium to produce it. Right? Okay, so moles of calcium cancels just like always, right? We cancel it, and then the only unit left is moles of calcium phosphate. So we take this, we multiply by this, divided by this, all right, and we end up with 0.0883 moles of calcium phosphate. 3PO4. 2. Okay, so that's all we did. We used the mole ratio and a stoichiometric calculation to determine how many moles of calcium phosphate will be produced in this reaction, right? And this just by multiplying by the mole ratio. This is the mole ratio, okay? Now, you notice that when you do this calculation, your product is in moles, right? So what we're going to do is we're going to take those moles, and just like before, okay, we're going to convert these moles into grams. So 0.0083 moles of calcium phosphate. Again, this is review, so you should know how to do this. Okay, put it over 1, and to convert from moles to grams, we need to use the mole ratio. Not the mole ratio, the molar mass. Okay, so I know that 1 mole of calcium phosphate has a mass of 310 grams. Calcium phosphate. Okay, this always works too. Units that I want, grams, over units that I have. If you always set up your problems in terms of units that I want over units that I have, the units that you have always cancel each other out. See? So now that these units are gone, the only units left are grams. So then you're going to take this, multiply it by this, and divide it by this. Okay? And that's going to give you your grams, which in this case is 27.73 grams, okay, of calcium phosphate. Okay? So we took the moles of the limiting reagent, okay? We used the mole ratio from the limiting reagent to the unknown, all right, to determine how many moles of that product are being made, right? Now, once we have the moles of the product, we're going to multiply by the molar mass to get the grams of this product. So in this reaction, using these grams, we were able to calculate that we should be able to produce 27.73 grams of calcium phosphate, right? So what does that mean in terms of yield? Well, percent yield is very simple, okay? This is a theoretical value. This is what you should get if everything runs to perfection, okay? This is considered what we call the theoretical yield, right? Theoretical yield. I know you probably can't read that, but that's what it is. So here's your theoretical yield. Now, a theoretical yield or a percent yield question is going to read something like this. If you run the experiment and you actually produce 25.74 grams of calcium phosphate, right? Sorry. What is your percent yield? So here's the formula for percent yield. Percent yield is percent yield, okay, is equal to your actual yield. And yield, all that means is like what you produced over your theoretical yield. Okay, and you're going to multiply that by 100 to give you your percent. Now, your theoretical yield, this is the yield that you calculate. Okay, anytime you do a calculation, it's always going to be your theoretical. Your actual yield is given, right? And it gives you a hint because it says actually produced. So when you run the experiment, right, you actually produce this amount, but you should be getting this amount. So here's what you do. You take your actual yield, in this case it's 25, right? 0.74 grams of calcium phosphate. Okay, and you're going to divide that by your theoretical yield, which in this case was 27.73 grams of calcium phosphate. Now, you're probably wondering why I keep writing calcium phosphate over and over again. Wouldn't it be easier? Well, because your units tells you that you're doing it right. See how this unit disappears and now you're just left with numbers times 100. Okay, so this number divided by this number gives me 0.94. Okay, you multiply that by 100 and guess what? You get approximately 94%. Okay, so this here, 94%, this is your percent yield. Okay, so once you take your actual yield, you divide it by your theoretical, and you multiply that by 100, you get your percent yield. So you produced or you made 94% of what you should have made. Okay, so that's it. This is how you do the stoichiometric calculation from the limiting reagent, and this is how you calculate your percent yield. Okay, if you have any questions about how to do this, just message me or email me and I'll try to answer your questions. All right, make sure and study for your test and good luck.